Let's solve Unit 3 Programming Languages and Computer Graphics questions. We are given a program segment and we are asked to find the output of the above code. Let's get into the main program. They have actually initialized an array. The values are 1, 2, 3, 4, 5. They have initialized a pointer to the array. Whenever such initialization takes place, the pointer will be initialized to the first value of the array. So the pointer is present in index 0. This initialization means the pointer is initialized to the 0th index of the array. Now they are asking us to print two values. One is pointer plus plus. This is post increment operator, and the other statement is pointer plus 1. Now we will interpret both these statements. So let's take the first statement. It is pointer plus plus. Whenever there is pre-increment operator, something like plus plus p, the increment first happens and then the printing happens next. But when it is p plus plus, the value is accessed directly as p. So after accessing the p's value only, the increment part will be taking place. So in this case we have pointer plus plus. It means the value in the pointer will be printed first. So what is the value in the pointer? It is 1. So initially we have star p is equal to 1. After it prints 1, it then increments the pointer's value to the next index. The pointer moves to the next position and now the pointer's value will be 2. So this statement will print 1. What about the next printf statement? It is having pointer of p plus 1. Here this is p plus 1, not post increment or pre increment. So here the p's value will be incremented. The p will be incremented by 1. It will be moving to the next index. So now pointer will have the value of 3. So now this pointer p plus 1's value will be 3. So the output is 3. So the first statement prints 1 and the second statement prints 3. So this output is given in the form of 1, 3. When you print this output, you will actually get 1, 3 without comma. But here they have introduced comma to say that they are different values. So if we take in that aspect, we can mark option 2 to be the right answer. This is just for readability purpose. I think they have introduced 1, 3. Other than that, if you take, the value will be 1 and 3, that will be printed continuously. So if you want to understand how this code works, I would recommend and I would suggest you to use an online C compiler, run the program. Wherever you get doubts, introduce some print statements, try to access every other value. This is how we have to learn programming related questions. Next question. Consider the following C code. What will be the output of the above code? We have to start from the main program and there is some function declaration. Int temp is equal to 0 is declared globally. It means it is not local to any other function. So this variable is initialized globally. Whenever we call the function, this particular variable will be incremented. It is globally initialized, so it is not local to any function. It is not local to the main function. It is not local to this function also. They check the value of y is 3 or not. If it is 3, they return the value of x. If it is not 3, they compute z. There is a recursive call to the same function and then the value of z is returned. So this is the function block they have given. Now let's get into the main function. So the first call will be function of 4, 81. From 4, 81, what you can understand? This is 4 and this is 81. It means x is equal to 4, y is equal to 81 and globally we have temp is equal to 0. So we have taken all the three values here. Now we have to get inside the function. We are declaring a z variable and we are incrementing the temp here. Temp plus plus is equal to temp is equal to temp plus 1. So already temp has 0 and now it is incrementing by 1 and the new value of temp will be 1 here. After incrementing temp, we have to check if y is equal to 3. Y is not equal to 3, so we are getting into the else block. Now we have to compute z is equal to function of x comma x is 4 and what is y by 3? It is 81 by 3. 81 divided by 3 will give you 27. So this statement is z is equal to function of 4 comma 27. Now the program is here. Immediately it goes for a recursion. So we are moving to the next call. So now when you have function of 4 comma 27, we'll again get into the function now. So now the value of x is 4, y is equal to 27. What is the value of temp that has been updated? It is 1. We should not start with 0 because temp is given outside the function. So once it has incremented the value of temp, the new value of temp should be used here. So now we know temp is equal to 1 from the previous part. Now we will get inside the function once again. We have to increment temp here. Temp is equal to the previous value is 1 and we are just incrementing it by 1. We get 2. We are checking for y is equal to 3. It is not true. So we are moving to the else part again. Z is equal to function of x is 4. Y divided by 3 is 27 divided by 3. Again we are going for a function call. It is recursively calling. This time the value is 4 comma 9. So we are moving to the next function call. The program pauses here and it goes for the next call. Again we have to go for x is equal to 4. This time y's value is 9 and the temp value is 2. Again we are getting inside the function. We have temp is equal to 2 plus 1 which is equal to 3. We are checking for y is equal to 3. It is not true. So we are moving to the else part. This time we have z is equal to function of 4 comma 9 divided by 3 and so z is equal to function of 4 comma 3. This will immediately call the function of 4 comma 3. Now the value of x is equal to 4, y is equal to 3 and temp is equal to 3 from the previously updated value. Now again we have to get inside the function block. Temp is equal to 3 plus 1 which is equal to 4. Now we have to check if y is equal to 3. Yes, it is true. If it is true, what it has to return? It has to return x into x into x. What is the value of x? It is 4. 4 into 4 is 16. 16 into 4 is 64. This value will be returned for this particular function. When we paused it for function of 4 comma 3, now this will give a value of 64 to z. So we are moving this 64 to the function calls next statement. So from here we compute z is equal to 64. So this particular function call is done now. We have to move to the previous call. When you go for recursion, after computing the final function call, we just apply the values to the above parts. The similar thing only we are doing here. So we are applying 64 to the return statement here, z into z into z. So this will have a value of 262144. Now whose value is this? It is the value of the previous function. So this function's value will be 262144. So when z is equal to fun of 4 comma 9, the value will be z is equal to 262144. So we are moving this value here. Z is equal to 262144 and the next immediate statement will be return of z into z into z. So this will give a value of a very big number. Now in C there is a range for integers. Integers maximum limit is this value. But z into z into z is giving this much big value. So when you run a program with such a big value, what it will do is overflow in conversion from long int to int. So this is a long int and this is int. When it has to convert from long int to int, the value will change from this long int number to 0. This is what the program will do. So when you apply this value to z into z into z, the value will be 0. Why it is 0? It is because it is exceeding the range of int maximum limit. So they have declared it as int z. You cannot have the value of z to be greater than this particular limit. You have to understand that. Till 262144 it is fine. But when you are multiplying 262144 for 3 times, you end up with a very large number which comes to the category of long integer and not normal integer. So that's why this conversion from long into int changes the value from this particular big number to 0. So now what is the function call of 4,27 giving us? It is giving you 0. So this value 0 will be taken to the previous call 4,27 statement where it is passed here. So this statement will be going to the next return statement now. So z is equal to 0 and 0 into 0 into 0 will also give you 0. So ultimately this particular function from where we started the program will have the value 0. It means fun 4,81 will yield the value of 0. Now we will move on to the printf statement. They are asking us to print the temp value. So what is the final temp value that we saw here? Temp is equal to 4. So option 2, 4 will be the right answer. From here I could have marked the answer, but I wanted to explain how this program execution will end and then go for the next statement, because we started with the first statement, function call with x value is equal to 4 and y value is equal to 81. So only when I complete this function call, when you execute it in a program, it will come to the next statement. So I wanted to go in the same sequence, that's why I completed the entire call and then I came for the printf statement. That moment when you find 3 plus 1 is equal to 4, and when you find this condition to be true, you need not go for any calculation like this. Instead, you can stop here, mark the value of temp and move to the next question. This is how you have to do in examination point of view. But in case, if some question paper is going to ask you what is the value of function call, for that purpose, for learning point of view, I have explained you how the execution will take place. Next question. Again, we are given a code segment with a swap function and a main function. This time it is C++ code. Let's see swap function overall. So we are passing %x and %y. We are using a temp variable and we are just swapping the values of x and y. So a simple swap function is given. Let's get into the main function. Int a is equal to 5, b is equal to 10. The swap function is called 2 times and they are asking us to print the value of a and b. Actually, when they give space here, this should also have space in the options. But in the options they have put comma, but here they have given just space. This particular method of passing arguments is called pass by reference. Pass the memory address of the variable to the function rather than the value of the variable. So whenever you have some value for a variable, say we have a is equal to 5 here and b is equal to 10, it will be stored in a particular memory address. So this address I have taken it for an example to explain you what happens. So if you ask me if this is going to be an exact address, no, this address will run so long, but I have just picked up only few characters to tell you how this process happens. So when they say x is equal to %a or y is equal to %b, that is when they send it by reference, what happens is x will have the value of the address of a and y will have the value of the address of b. So when you want to check how this address is getting printed, use %p instead of %d in C. If you take in C language, if you use %p %a, this will print the memory address of A. How will you print the value of A? We will usually use printf %d A. This is how we will be printing the value of A. This is for the value and this is for the memory address. Now we are getting into swap of A comma B. So what does this swap do? Initially A is having 5, B is having 10. but x gets the value of address of A and y gets the value of address of B. What happens inside the swap function? We are swapping the values of x and y. So ultimately x will have the address of B and y will have the address of A. So when it comes out of this particular function call, the values of A and B will be swapped. That is, A will become 10 and B will become 5. That is what is given here. What happens when you go for second call of the same swap function? Now we know A has the value of 10 and B has the value of 5. So X is getting memory reference of 10 and Y is getting the memory reference of 5. So this particular value is associated with this address and this value is associated with this address. So based on the value only the address will be taken. So 10 is having FB and 5 is having FA. Now we have to get inside the swap function. We are swapping the positions once again. So X will get the value of this memory address and Y will get the value of this memory address again. So what is in FA? It is 5. What is in FB? It is 10. So after this swap, A will become 5 and B will become 10. That is what is given here. Now when you want to print A and B value, what is A's value now? It is 5 and what is B's value? It is 10. So 5, 10. Option number 1 will be the right answer. If you want to understand this program in a better way, instead of ampersand x and ampersand y, just use void swap int x int y and see how the execution happens. This change will never happen. You print A and B here also. Just give C out A and then B. So introduce as many as print statements in between the code to understand what happens in the execution. This is how you can learn. Even if you are not used to programming all these days, you have to get used to these programming kind of questions. So practice as many times in some online compilers so that you can get used to such problems. Next question. Consider the function in C code. So they have given a recursive function here. How many times star is going to be printed if the function is called with call 10, 10. So call A, B is call 10, 10. From this you can infer the value of A and B. A will be 10 and B will be 10. So let's first understand what is in the code. So they have given if and else block inside a if block. So the first if block will test whether B is equal to 1 or not. If B is not equal to 1, inside the if block they check whether A is not equal to 1 or not. If it is not equal to 1, if block will be executed. If it is equal to 1, else block will be executed. Whenever B is not equal to 1 and A is not equal to 1, a star is printed. They are asking how many times this star will be printed. So we will get into the first call. Call of 10, 10. From this we can get the value of A and B as 10. Now we know B is not equal to 1. B is equal to 10. So it enters the if. We know A is also not equal to 1. So it prints star once and now there is a recursive call. A by 2, B. What is 10 by 2? It is 5. What will be the next call here? It will be call of A by 2 means it is 5, what is B? It is 10. So call of 5, 10. So again we are taking A and B values here. A is equal to 5 and B is equal to 10. So both are not equal to 1. We are again printing a star here. Now we have to make a call A by 2, B. So what is A by 2, B? It is 2, 10. The B's value is not getting changed here. Only the A's value is getting changed because they have given A by 2. So now we will go with call of 2, 10. Here the value of A is equal to 2 and B is equal to 10 again. So one more time star is getting printed. Actually the correct term is asterisk. So this star is getting printed. A is equal to 2 by 2 comma b. So this time the call statement will be 1 comma 10. When you go for a call with 1 comma 10, we have b is not equal to 1. This is right. But is a not equal to 1? No. So this time we are moving to the else part. So in the else part, we are decrementing the value of b by 1. So b is equal to 10 minus 1, which is equal to 9. Now the value of b will be 9. What is the next call that is given? Call of 10 comma the current value of b is 9. So this goes to call of 10 comma 9. Now again we are starting with a is equal to 10. Just see how it is getting repeated. When both are not 1, this asterisk is printed, and again we are going for a by 2 comma b call. So this is call of 5 comma 9. So in all these 4 places b was 10. Now b is 9 from here. So 5 comma 9, again asterisk will be printed. 5 by 2 is equal to 2. Again we have 2 comma 9, again asterisk will be printed. This time we have a is equal to 1. So when a becomes 1, this if block will not be executed, but it goes to else block. We are getting into the else block where b's value is decremented to 8. So from here you can understand one thing. So whenever b's value is decremented, a set of call is repeating for a specific number of times. We have 10, 5, 2, 1. For every 10, 5, 2, 1, we have the same b value. And in this order, 10, 5, 2, 1 order, 3 times asterisk gets printed. And the 4th time, we don't have any printing. So for every b value, when b is equal to 10, it is printed 3 times. When b is equal to 9, it is getting printed 3 times. Now we will generalize this for other b values. So we will check whether b is equal to 1 or not. We will check whether a is equal to 1 or not. So this is outer if, this is inner if condition, and this is the respective else condition. Now b's value is equal to 8. So when b is equal to 8, we will have a is equal to 10, 5, 2, for which this particular symbol will get printed. Then for the 4th call, b will be decremented by 1 value. b is equal to 8 minus 1, which is equal to 7. Now what will be the next call? It will be 10 comma 7. So now the value of b is 7. Once again we will have a is equal to 10, a is equal to 5, and a is equal to 2, for which the particular symbol gets printed, and then we are decrementing it to 7 minus 1, which is equal to 6, the new value of b. So this is 10 comma 6. When we call 10 comma 6, b is equal to 6, again a will have all these 3 value and symbol will get printed again. We are decrementing the value by 1 when a turns 1. So now the call will be 10 comma 5. So this will happen for 5, this will happen for 4, this will happen for 3, and this will happen for 2. When b becomes 2 minus 1, which is equal to 1, the call will be 10 comma 1. Now just get into the if block here. Is b not equal to 1? No, b is equal to 1. Once b is equal to 1, the particular call is terminated. It means it comes out. So the program gets terminated when b is having the value of 1. So for every b, this particular symbol, asterisk symbol, is printed for 3 times. And the 4th time the b is getting decremented as I explained before. B had the values of 10, 9, 8, 7, 6, 5, 4, 3, 2. When it became 1, it came out of the call. So 1, 2, 3, 4, 5, 6, 7, 8, 9. B had 9 different values, and every time 3 asterisks were printed. So 9 into 3 will give 27 times that particular symbol got printed. So let's check it manually. 3, 6, 9, 12, 15, 18, 21, 22, 23, 24, 25, 26, 27. Option number 4, 27 will be the right answer. If you ask me for exam point of view, you need not get into this part. When you find for every value of b, this symbol is getting printed for 3 times. Just by computing the value of B, you can conclude it is for 27 times. You definitely know until B becomes 1, this particular call will be going on again and again. When B is equal to 10, we know it is printed 3 times. When we found B is equal to 9, it is getting printed for 3 times. Till B is equal to 2, it will be printed for 3 times only. This you have to find it through these 8 calls. So if you compute this, it will be more than enough for you to understand what is happening inside the code segment. Once you find this is going to be the logic, without getting into this particular part, you can conclude the answer is option number 4. Next question. Consider the following code. We are once again into C code. Here they have given 2 functions, F1 and F2. We will get into the main function. We have 2 character strings. One is A, which is having the value 1, and the other one is B, which is having the value 2. So what is this star x star x? We'll just see what they are. The statement character asterisk A is equal to 1 creates a string literal. Generally, if you take character, it will have only one particular character here. When you have asterisk and a variable name, you can have multiple characters together. So what is a string? It is a set of characters. So here they have initialized 2 character strings. One is A and other is B. So this string is composed of 3 characters. Then what about this asterisk x? This particular symbol is a pointer to the string. So we know for integer and all we use P is equal to A like that. It means this is a pointer. But this character string already has an asterisk symbol here. So in order to mention it as a pointer to the string, you automatically introduce another asterisk here. So now they have given calls to the 2 functions. First we are calling F1 function and second time we are calling F2 function. In F1 function we are just passing the values of A and B. In function 2 we are passing the reference of A and B. So let's get into F1 of A and B. Now this is actually a string literal. It has not passed any kind of reference. Already we saw in one code statement, only when the reference is passed the values will get swapped. What is happening here is we are declaring T1. We are just swapping. T1 is equal to X. X is equal to Y is equal to T1. A simple swap operation is happening here. And once you come out of this function, the values will not be swapped. A's value will be retained as 1 and B's value will be retained as 2. There is no change. The function just changes local pointer variables and the changes are not reflected outside the function. Now what about the next function call with ampersand A and ampersand B? Here the strings are swapped. We are assigning T1 is equal to asterisk x is equal to asterisk y is equal to T1. So here we are swapping it using the pointers. That is what it's mentioned as. It swaps strings by swapping pointers. Here's the difference and that's why the declaration goes like pointer to the string instead of a string literal directly. When character pointer for strings are used, change x and y to point each other's data. This particular process is called as swapping the pointers. In a function, if we want to change a pointer, then we need to pass a pointer to the pointer. This is why we are using double asterisk symbol here. There are actually 2 methods to swap strings. One is using swapping pointers and the other is using swapping the data when you use character array. So this swapping pointer is what they have done in this particular F2 function. And this swapping data, I will leave it to your learning. There are lots of references even in your books and in the web. You can just go and have a look how swapping occurs in both the methods for a better understanding. Once we know the strings are swapped here. So what will be the value of A now? It will be 2. And what will be the value of B? It will be 1. The values of A and B are swapped in the F2 function. First we are printing F1 function. It should start with 1, 2. We will retain 1 and 3 now. From second function call, what did we get? We have swapped the string, so it is 2, 1 now. So 1, 2, 2, 1. Option number 1 exactly matches the output. Option number 3 is just repeating the same thing, but F2 will definitely swap the strings, so 3 is also wrong. So this option 1 will be the output of the above code. Only when you execute the code and see, you will definitely understand what is happening inside. As long as you see in the screen, everything will be so good, so comfortable. But when you get into the exam hall, this might not help everyone. Some may be very comfortable with such kind of learning, they will manage. But it does not suit everybody is what I wanted to say. Next question. Consider the following C program. We are given an array X 2, 4, 6, 8, 10. A is declared as integer, B is initialized as 0. And there is a pointer initialized as x plus 4. So let's take the array first. The values are 2, 4, 6, 8, 10. And now we have the index 0, 1, 2, 3, 4. When this statement is given, we know the pointer will be pointing to x of 0. That is the first address. But when it is x plus 4, it means it is pointing to the fourth index. The value of pointer y will be 10. When it is asterisk y is equal to x, it is referring the first index element. When it is asterisk y is equal to x plus 4, it is referencing the fourth index element. What is the fourth index element? It is 10. So the value of the pointer will be 10. Now we are given a for loop here. A is equal to 0, A is less than 5. It means A can take the value of 0, 1, 2, 3, 4. Inside the for loop, we are given calculation for B. So this evaluation is what we are going to do it step by step now. B is equal to B plus, you have y pointer minus A minus of pointer y minus A. So when you calculate B, we will use the values from the other two columns. So let's first understand what is this part. Star y and star y minus 0 is same. So when this becomes star y minus 1, it refers to the previous element. When it is y minus 2, it refers to the previous element. Again from here, when it moves backside, it goes to the previous element. So this is how the movement will be given for y minus 0, y minus 1, y minus 2, y minus 3 and y minus 4. This is when y minus the value is given here and the asterisk is placed outside. Then what about asterisk y minus a? What is asterisk y? It is 10. So this can be evaluated as 10 minus the value of a. We are just going to use it as 10 minus a because we know asterisk y is equal to 10 based on this particular initialization. Now we will get into the for loop. Let's take a is equal to 0. So we know this is 10 minus a. So 10 minus 0 is going to be 10. What about y minus 0? The value is 10 here. You should not look at the index, but you should look at the value only. This is for computing purpose. I am just telling you where it will come and sit. But you have to access only the elements present in the index. So we are starting with 10. So this particular expression will yield 10. Now b is equal to b plus. What is the value of b? B is actually initialized to 0. So 0 plus, let's take this to be column C2 and this is column C3. So this value should be taken from C2 and this value should be taken from C3. What is C2 column value? It is 10. So this 10 is placed here. What about C3 column value? It is 10 again. And we have subtraction here. So it is minus 10. 10 and 10 will get cancelled. B is equal to 0. So we have the value of B to be 0. We'll go for A is equal to 1. 10 minus 1 is equal to 9. What about y minus 1 here? We have to move to the previous element. It is 8. So I have just placed the index part here. So the respective element will be 8. So we are getting 8 here. B is equal to, already the value of B is 0 only, plus C2 column has 9, C3 column has 8, 9 minus 8 will give you 1. Now the value of B is 1. Let's increment A. 10 minus A's value is 2, which is equal to 8. Now y minus 2 will point to 6. B is equal to, the value of B is 1. So 1 plus C2 column it is 8, C3 column it is 6. So 1 plus 8 is 9, 9 minus 6 is 3. So B is equal to 3. Now A is incremented to 3. 10 minus A is 10 minus 3, which is equal to 7. Now y minus 3 will be 4. B is equal to 3 from the previous part plus 7 from C2 and 4 from C3. 10 minus 4 will give you 6. So B is equal to 6. What about A when it is incremented to 4? 10 minus 4 will give you 6. Y minus 4, this part will yield 2. B is equal to, already it is 6, here also it is 6, it is minus 2. 6 plus 6, 12 minus 2 is 10. So the value of B is 10. When A becomes 5, it will get out of the loop. Now we have a print statement. It is asking for the value of B. What is the B value that we found at last? It is 10. Option number 4, 10 will be the right answer. This code segment might be very easy for you to see, but if you don't understand this part and this part, this computation may go wrong. Work this code segment in an online compiler. Try to fetch the values separately for this expression and this expression. First you try to print y minus 0, y minus 1, y minus 2, y minus 3, y minus 4. Understand how it accesses the array. Then go for this calculation inside the loop. After you understand column C2 value and column C3 value, then you get into the evaluation part of B. Next question. Which of the following is correct way to declare a functional pointer in C? What is the general syntax to declare a functional pointer? We will have a return type. Then we will have function pointer name along with the pointer symbol asterisk. Then we will have the parameters as type 1 and type 2. It's having 2 stars here, so 3 and 4 cannot be in the option. So which one should we consider, 1 or 2? The declaration of a function pointer variable has an asterisk just before the function variable name. Proper nesting requires a pair of parentheses around the two of them. It means the pointer symbol and the function name together should be enclosed in parentheses, which states that option 1 is wrong, but option 2 will be the right answer for this question. This is int, open parenthesis, close parenthesis, pointer symbol and the function pointer name that types as int comma int. It is actually matching with option number 2. Next question. What will be the output of the following C code? So we have 5 array values. This time we will take it vertically, 10, 20, 30, 40, 50. How this array will be arranged in the memory block? So let's take a sample address of 1000. We know every integer is of 4 bytes with respect to C programming language. So if this value 10 has a base address of 1000, then the next value will be 1000 plus 4, which is equal to 1004. The third value will have plus 4, 1008. The fourth value will be placed in plus 4, 1012. Then the fifth value plus 4, 1016. This is how the address will be there. So we know whenever a pointer is going to point something like ARR, this will be referring to ARR of 0, the 0th index. So this is 0th index, this is first index, this is second index, this is third index and this is fourth index. So ARR is an integer pointer which points the first element of the array. That is what I explained here. So now if we take this to be ARR, this will be ARR plus 1, this will be ARR plus 2, this will be ARR plus 3, this will be ARR plus 4. ARR plus 1 means if we move ARR by 1 position, it will point the second element. When we move it by 2 position, it will point the third element. When we move it by 3 positions, it will point the fourth element. When we move it by 4 positions, it will point to the fifth element. You have to understand this particular order. This is not different from what we have seen already. So let's go for the next line of code. Int pointer is equal to, they have given something like ampersand of ARR plus 1. Let's get into the print statement. We are actually asked to print two values. One is star of ARR plus 1 and another is star of P minus 1. So far we have seen only till here. What is ARR plus 1? It is this part. When we say asterisk of array plus 1 or array plus 2, we have to pick up the element. So what is the value present in ARR plus 1? It is 20. So whichever options has 20 in the first place can be retained. We can rule out 1 and 3. What about ampersand of ARR? This is actually an integer array pointer which points to the whole array. It means when I say ampersand of ARR, all these elements are referenced together as ampersand ARR. So this particular block is referred as ampersand ARR. This ampersand means it refers to a block of array elements. For this program, it refers to all the 5 elements together. So when we say it is ampersand of ARR plus 1, it means we are moving by one position where it will point to the next block of 5 elements. So let's take another 5 elements and their addresses. So 1016 plus 4 will give 20, 20 plus 4 24, 24 plus 4 28, 28 plus 4 32, 32 plus 4 is 36. So this set of 5 elements is ampersand ARR, means the next set of 5 elements will be ampersand ARR plus 1. If this is going to be without ampersand, just incrementing one position, you are able to traverse the elements. When this is with reference to a particular block, plus 1 will actually move block to block. If this is going to be block 0, plus 1 will be moving to block 1. If ARR is for a particular element, ARR plus 1 will move to the next element. Similarly, if ampersand ARR is for a particular block, ampersand ARR plus 1 will move to the next block. This is what is mentioned in the diagram here. This is integer star, which is in this format. Instead of this particular location part, we are mentioning it is the second block. So from here, pointer is referring to the first value of the second block. So why are we mentioning it into the first element? When I say pointer is equal to array, which element are we referring here? We are referring to the index 0 element. Similarly, for this block, which is the index 0 element, it is this one. So this is index 1, index 2, index 3 and index 4. Based on that, the pointer is placed here. Previous question we saw asterisk of y minus 0 is one element. Asterisk of y minus 1 is the previous element. Now just compare that learning here. Asterisk of p minus 1 will be previous element. So what will be the previous element to this particular memory location? The previous element will be the last element of the previous block. I will take this to be 60, 70, 80, 90 and 100. Let's take this as value. If these are going to be continuously arranged in the memory, because it has 1016, it has 1020. Just imagine a block like this. So let's take this way. So till here we know it's a block. Now the pointer is present here and it is continuously allocated because it is 1016 here and the memory is 1020 here. When I say it is star of p minus 1, it means you have to move one element before as we did in the previous problem. What is the previous element as per this continuous memory allocation? It is the element 50. So when you want to print p minus 1 here, it will print 50. Option number 2 will be the right answer. Option 4 is wrong again. So if you take this to be the pointer, the previous element you can take it as 40. So you might make a mistake there. That's why they have even included this option. So the pointer is actually referring to the 0th index of the first block. When it is continuously arranged, it will refer to the previous element, means it will go to block 0 and the 4th index element. So this will be the previous element. When you think it as continuous memory allocation, you will be able to understand how we get p minus 1. But in order to understand this ampersand ARR plus 1, you have to look it in this particular aspect. Next question, what is the output of the code given below? It's a C++ code and it has a base class and a derived class. So base class is having a constructor. What is a constructor? Any member function or any method in the name of the class will be constructor. So we have a constructor here and we have a destructor here. Anything with the symbol, tilde symbol we will say, that is a destructor. Similarly, in derived class, we have a constructor as well as destructor. Inside the main function, they are actually creating an object and they are deleting the object. Here, the base class pointer is pointing to a derived class object. So just get inside the constructor and the destructor. They have just given a print statement. This is base constructor, this is base destructor, this is derived constructor and derived destructor. So here they are asking for the output. It means they wanted to know when an object is created, what will be the order of execution, whether base is getting executed first or derived is getting executed first. Similarly, by means of deleting the object, they are asking which destructor is invoked first. So we have two aspects for the question. We have to know which constructor is invoked first and we have to know which destructor is invoked first. Let's see some statements. When the derived class object is made, the base class constructor is called first, which means this particular constructor is called first and automatically this will be called next. So the order of constructor will be base constructor statement and then derived constructor statement. This is the case of constructor. It's a good practice to make all destructors virtual. So they have made it as virtual here. Why have they asked us to make it as virtual? Non-virtual destructors might result in cases where the derived class destructor is not called. So if you take the fourth option, derived destructor is not called. But here they have mentioned the base destructor with the keyword virtual, which means in this case definitely derived destructor will be in the option. So from this point we can rule out option 4 from the answer list. So whenever non-virtual destructors are there, there is a possibility where the derived class destructor is not called. When it is called, what does it mean? You will have this statement printed here. Since the statement is not printed here, we are ruling out option 4. While creating an object, this will be the order. While deleting the object, how will the order of destruction be? The current class destructor is called. So we are actually creating a pointer to the derived class object. So now we are in derived class. So the current class here is derived class. So the current class destructor is called. Can we call the current class destructor? Yes, we can call because the base class is declared with the virtual keyword. So what is the destructor statement? Derived destructor. So the first statement will be derived destructor. Data members are destroyed in the reverse order of construction. We are not getting into this part as per this code segment. The parent destructor is called. What is the parent destructor? It is the base destructor. So what is the statement here? Base destructor. So initially the constructor will be called when the object is created, and then when the object gets destroyed or deleted, the destructor will be called. So the output will have the constructor set of statement first. What is the constructor set of statement? First base constructor is called, then derived constructor is called. We should start with base constructor. Two options are starting with base constructor. So we will rule out even option 3. Base constructor and derived constructor are here. Base constructor and derived constructor are here. So constructor part is done. Now what about destructor? We have to go with the order of derived and base. So here it is derived destructor and base destructor, but here they have called base destructor first, which is wrong. So option 2 is also ruled out. Option 1 will be the right answer with the correct order. So these two are for constructors and these two are for destructors. So when an object is created, we call the constructor, and when it is deleted, the destructor part is called. When you don't have virtual here, derived destructor may not be called. That's why this makes it sure that derived destructor is definitely called. So these are little points that we have to learn while we are preparing for such questions. Next question. Which of the following C++ statements correctly declares an abstract class? So what is an abstract class? A class is abstract if it has at least one pure virtual function. Only one option is having the virtual keyword. So the other three can be ruled out. What about a pure virtual function? It is declared by assigning 0 in the declaration. This is what they mean by it. Option number 1 will be the right answer. Next question. Arrange the following steps of file handling in C in the correct order. The operations can be performed on a file in this way. First, we will go for opening a new file, or we have to open an existing file. So even for creation, you have to open a particular file. Once you open a file, you can always go for a check in the code part. You have to check whether the file can be opened. It is related to permission, or whether the file is existing or not. So whether it is in the case of existence or whether it is in the case of permission, we have to check whether the file can be opened. So when the file is not found or when the file cannot be opened, it returns null. This is actually a condition that you have to specify in the C code segment. If you don't check and specify them, this will result in an error. This is what they say, check for error. The first part is when you have to open a particular file, and the second part is you have to check for some kind of error. You have to check whether the file is existing. Even if it is going to exist, you have to check whether you have appropriate permissions to access it. So this is checking for error. After opening an existing file, you can read from the file, or if you are opening a particular file, you can write to the file. So reading and writing can happen simultaneously. You can update an existing file, you can do whatever you want. This can be taken as the next step. Once the work is over, you have to close the file. So open the file will be the first step. Only one option is starting with C. So open the file followed by check for error followed by read from or write to the file followed by closing the file. Option number 3 will be the right answer. 1, 2, 3, 4. This will be the order. Next question. Which of the following statements about pointers in C are true? Pointers can be used to access array elements. So far in all the output code segments, we have been seeing the same thing only. So definitely A is true. So any option that excludes A can be ruled out at this stage itself. Now we have to check whether B is true or C is true. Let's take the next statement. Pointers can store the address of another pointer. Yes, they can store the address of another pointer, and we call such pointers as double pointers or pointers to pointers. So definitely this statement is also true. Without even looking C and D, you can mark option number 2 as the right answer. So we know 1 is also wrong. Now we will understand why C and D are not true. Pointers are automatically dereferenced in expression. It's not difference, it is actually dereferenced. What is dereferencing a pointer? It means accessing the value stored at the memory address pointed to by the pointer. We actually dereference it using this particular symbol. When you mention a pointer, it actually denotes the address of the variable. Only when you use asterisk pointer, it will denote the value. This is actually dereferencing a pointer. In C and C++, pointers are not automatically dereferenced. You need to explicitly use the dereference operator to access the value stored at the memory address pointed to by the pointer. So we are using pointer to store the address of the variable. In order to access the value of the variable, you have to dereference it. We can mark C as false. What about D? Pointers cannot be used to access structure members. This is also false. To access members of a structure using pointers, we use the arrow operator. You could have seen such accessing code in structure related code segments in C. So definitely this is possible. So D is saying it cannot be used. Not so. It can definitely be used to access the members of a structure. Next question. Which of the following are true about constructors in C++? Constructors are member functions of a class that are automatically called when an object of the class is created. Actually, they are used to initialize objects. One class can have multiple constructors. So they may differ by the number of parameters or by the type of parameters, which says a constructor can be overloaded. So overloading is done through this point. A is true. A constructor does not have a return type. Yes, a constructor cannot have a return type. You cannot even mention void there. Void is actually nothing, but even that is a return type. You cannot even mention that one. It is because constructors are basically used to initialize the object. They are not used to return some value. So B is also correct. So whichever options includes A and B can be kept. The remaining options are ruled out. Now we have to check whether C is right or not to mark the answer. A constructor must be declared as a friend function. What are actually friend functions? They are non-member functions that are given special access to the private and protected members of a class. Usually, other than the member functions, you cannot access the particular class private and protected members. So, friend functions can be given that privilege of accessing private and protected members of a class. They are declared using the friend keyword inside the class definition. So what about constructors? Constructors do not need to be declared as friend functions because generally constructors are going to be called only when the object of that particular class is going to be created. There is no mandate condition that they have to be declared as friend functions. So here the statement is must be declared, which makes it as a mandatory condition. It is not a must condition. So C is wrong. What about D? A constructor is called when an object is destroyed. You can close your eyes and mark this as wrong. When they say a particular object is going to be destroyed, destructor will come into existence and not constructor. Destructor is related to the destruction of an object and constructors are related to the creation of objects. So C is also not included. We can mark option number 4, A, B only as the right answer. Next question. Match list 1 with list 2, HTML, DHTML, XML, Java. If you would have practiced the previous year question, the cancelled June 2024 exam, I would have explained about HTML, DHTML and XML there. So HTML is actually used to create web pages. So we can map HTML to 2. Defines the structure of web pages. A2 is available in 2 options. The rest of the options can be ruled out. What about DHTML? The question in June 2024 was which languages given are markup languages, and DHTML was also one of the option. But I have told you there itself that DHTML is not a particular markup language. It is a term that is used to give dynamic behavior to the web page. So which statement justifies that? The first one. So B will be mapping to 1. Allow for dynamic and interactive web pages. It is because of the use of HTML, CSS and some scripting languages like JavaScript. So when you include CSS and scripting languages along with HTML, that will induce dynamic behavior or that can give some interaction to the web pages. So DHTML is a term and it's not a particular markup language. What about XML? So XML is used for data storage and transporting. When you want to transport data from one particular web document to another document, you can use XML. So C will be mapping to 4. B1, C4. So here itself we can find 2 is also out of the race. What about Java? Java can be mapped to 3. Object-oriented programming language for web applications. So this is also right. Option number 3 will be the right answer. With this, we are completing Unit 3 solutions.